On paper, Kimi K3 has 2.8 trillion parameters. That is 2.8 trillion reasons for every AI executive in Silicon Valley to suddenly discover meditation. Within days of launch, Moonshot AI's new model topped Arena's web development leaderboard, climbed to third place on Artificial Analysis's Intelligence Index, and attracted so much demand that Moonshot temporarily stopped accepting new subscriptions because its compute capacity was getting crushed. So, did a Beijing startup just end America's AI monopoly? Not exactly. The real story is more uncomfortable, and more important for investors. The United States still appears to lead at the absolute frontier. But Kimi K3 challenges three assumptions at once: that frontier intelligence must come from an American lab, that it must remain closed, and that customers must accept whatever price the largest model providers decide to charge. This is not the end of the AI race. It is the end of a very comfortable version of the race. Moonshot introduced Kimi K3 in July 2026 as a native multimodal model with a 1 million token context window, designed for long-horizon coding, knowledge work, visual reasoning, and agentic tasks. The headline number is 2.8 trillion parameters. But before anyone compares that number directly with every dense model on Earth, we need to add one extremely important footnote. Kimi K3 is a mixture of experts model. Think of it less like one giant brain using every neuron at the same time, and more like a company with 896 specialist departments. For each token, the system calls only 16 of those experts into the meeting. So yes, the company has a gigantic employee directory. No, all 896 departments are not joining every Zoom call. That sparse design matters because total parameter count is not the same thing as active computation per token. Moonshot says K3 combines stable latent MOE with Kimi delta attention and attention residuals, and claims roughly 2.5 times the scaling efficiency of Kimi K2. In plain English, Moonshot is not merely adding more parameters. It is trying to route information more efficiently across both long sequences and very deep networks. That is the technical reason K3 matters. The 2.8 trillion figure gets the headlines. The architecture determines whether the headlines survive contact with reality. The honest answer is, sometimes, yes, overall, not yet. Moonshot's own launch material explicitly says Kimi K3 still trails the most powerful proprietary systems from Anthropic and OpenAI in overall performance. That admission is important, because it prevents the story from becoming nationalist benchmark karaoke. Independent evaluations still show a major leap. Artificial Analysis gave Kimi K3 an intelligence index score of 57, placing it third at the time of evaluation. That put it in the same broad performance tier as Claude Opus 4.8 and GPT 5.5, while still behind Claude Fable 5 and GPT 5.6 Sol. On Arena's WebDev leaderboard, Kimi K3 reached an ELO score around 1,682 and occupied the top position in the latest snapshot used for this script. On Val's cross-domain index, it scored about 74.7% and ranked third among the tested group. That is not, China has one artificial intelligence. It is also not, cute open-source model, come back when you grow up. K3 is operating close enough to the frontier that enterprises, developers, governments, and investors now have to take the open model alternative seriously. But benchmark victories require context. Different models are tested with different agent harnesses. Maximum reasoning settings can dramatically increase time and token use. Vendor case studies are demonstrations, not audited financial statements. And a model that wins a coding benchmark can still make a very expensive mistake in statistics, law, medicine, or production infrastructure. Even Moonshot lists limitations. K3 can be excessively proactive, its performance can become unstable when thinking history is not passed correctly, and the company acknowledges a noticeable user experience gap versus the strongest proprietary models. In other words, K3 may be a brilliant engineer who occasionally redesigns your entire factory because you asked it to move one chair. The biggest strategic claim is not merely that K3 is powerful. It is that K3 is open. But timing and terminology matter. At the research cutoff for this script, Moonshot had scheduled the full model weight release for July 27th, and the official Hugging Face page was still showing an upcoming release countdown. Until the files, license, inference code, and technical report are actually public and inspectable, the most precise description is, a hosted frontier model with a committed open weight release. And even after the weights arrive, open does not mean easy. Moonshot recommends deployment on supernode configurations with at least 64 accelerators. The model uses MXFP4 weights and MXFP8 activations to make its scale more manageable, but this is still not a weekend laptop project unless your laptop is secretly a data center with a keyboard attached. This creates a strange new category: open weights, closed garage door. Large cloud providers, sovereign AI programs, research institutions, and well-funded enterprises may be able to deploy or fine-tune K3. Most individual developers will access it through an API or a hosting partner, so the openness changes control, auditability, customization, and bargaining power, but it does not eliminate infrastructure economics. The official API price at launch was 30 cents per million cached input tokens, $3 per million uncached input tokens, and $15 per million output tokens. That can be attractive relative to some top proprietary systems, especially with high cache hit rates. But it is not universally cheap, and K3's maximum reasoning mode can consume substantial time and output. Artificial analysis measured roughly 33 output tokens per second and a very long time to first token in its evaluation. K3 always thinks. Sometimes it thinks long enough for you to reconsider the question, your career, and possibly the nature of time. The most important effect of Kimi K3 may not be who owns the #1 benchmark trophy this week. It may be what happens to the economics of the model layer. For the last several years, the leading closed model companies have benefited from scarcity. Only a few labs could train frontier systems. Customers had limited substitutes. Better intelligence supported premium pricing, and premium pricing funded the next training run. K3 weakens that loop. If an open-weight model can deliver near-frontier performance in coding, research, and agentic workflows, enterprise buyers gain leverage. They can compare hosted providers, negotiate pricing, self-host selected workloads, customize behavior, or keep sensitive data inside controlled infrastructure. That does not destroy the closed model business. OpenAI and Anthropic still have major advantages in product polish, safety systems, distribution, enterprise integration, brand trust, and the absolute frontier of performance. But the market may shift from, which single model do we worship, to, which model is best for this workload, at this latency, with this security requirement, at this price? That is a much less comfortable market for anyone relying on model exclusivity alone. The likely beneficiaries are broader than Moonshot. More capable open models can increase demand for inference chips, high bandwidth memory, networking, liquid cooling, data center power, inference optimization, model routing, and specialized cloud capacity. Cheaper intelligence does not necessarily reduce compute demand. It can unlock more use cases, longer agent runs, more parallel agents, and vastly more tokens. Moonshot's own capacity problem is evidence of that paradox. Strong demand forced the company to pause new subscriptions and prioritize existing paid users. The model was supposed to demonstrate abundant intelligence. Instead, it immediately demonstrated scarce GPUs. For semiconductor investors, that is not a minor detail. Kimi K3 will inevitably be used as evidence in the debate over US chip restrictions. One side will argue that China built a near-frontier model despite restricted access to the most advanced accelerators, proving that export controls failed. The other side will point to Moonshot's compute shortage and the enormous infrastructure required to serve K3, arguing that the restrictions are clearly creating real constraints. Both sides are simplifying. Restrictions can slow access to compute without stopping algorithmic progress. Scarcity can also force teams to improve architecture, sparsity, quantization, kernels, scheduling, and training efficiency. At the same time, efficiency gains do not make compute irrelevant. A model that is more efficient but used by millions of people can require more total infrastructure, not less. Kimi K3 therefore does not prove that chips no longer matter. It proves that chips, algorithms, capital, software, and deployment engineering are one integrated system. Blocking one layer may change the route. It does not guarantee the destination disappears. There is also a serious unresolved controversy around training data and model distillation. Anthropic has accused Moonshot of using millions of Claude exchanges through fraudulent accounts to extract capabilities. Distillation itself is a standard and legitimate technique when used with authorization. The dispute is about access, scale, and alleged violations of terms. Those accusations are significant, but they remain allegations from a competitor, not a final legal judgment. A credible analysis should neither ignore them nor present them as proven fact. For investors, the practical point is that frontier model competition is becoming entangled with intellectual property enforcement, sanctions risk, cloud access controls, and national security policy. The technology may be open. The geopolitical environment will not be. There was never a literal American monopoly on artificial intelligence. China already had DeepSeek, Qwen, GLM, Minimax, and other competitive model families. Open-source research has always crossed borders. And many of the researchers building American models were educated, born, or trained around the world. What the United States did have was a powerful concentration of advantages: the best chips, the deepest capital pools, the leading cloud platforms, the strongest frontier labs, and the global narrative that serious AI innovation happened first in Silicon Valley. Kimi K3 attacks the last part most directly. It says a Chinese lab can build a model at enormous scale, place near the top of independent evaluations, compete in high-value coding and knowledge work, and prepare to release the weights into the global ecosystem. That changes expectations. It tells enterprise buyers that alternatives are real. It tells developers that open models may no longer require a major capability discount. It tells American labs that premium margins cannot be defended by benchmark leadership forever. And it tells policymakers that restricting hardware is not the same as controlling innovation. But K3 does not erase America's lead in the strongest closed systems. It does not solve the cost of serving a 2.8 trillion parameter model. It does not remove latency, reliability, safety, or deployment challenges, and it does not turn every benchmark chart into revenue. A model can be technically impressive and commercially difficult at the same time. In fact, that may be the most normal thing in artificial intelligence. The 2.8 trillion parameter number is not the real shock. The real shock is that the frontier is becoming plural. There may no longer be one permanent leader, one architecture, one national champion, or one business model. Closed systems may lead in absolute capability. Open-weight systems may lead in customization and ecosystem adoption. Smaller models may dominate cost-sensitive workloads. Agent platforms may capture more value than model providers. And the largest economic winner may still be the infrastructure supplying all of them. So here is the final verdict. Kimi K3 did not end the American AI monopoly, because the monopoly was never as complete as the headline suggests. What it did end was the comfortable assumption that the next frontier-class model had to be American, closed, and prohibitively expensive. The monopoly on the narrative is over. The race is not. And for investors, that means the most important question is no longer simply, who has the smartest model? It is, who captures the value when intelligence becomes competitive, abundant, and extremely hungry for compute? This is Eagle Research. Subscribe for more evidence-driven analysis on AI, semiconductors, and the companies building the next technology cycle.